We're going to talk about systems, and basically everything in this chapter is kind of considered a system of some sort, or ecosystems in general. You're always going to have something that comes in from where? So how does something go into the system in the environment, let's say? Well, I just kind of gave it to you. In the environment. And then it's going to go throughput. What do you think that means? Okay, it's going to be used or flow through the environment in some way, and then it's going to exit where? Let's say if it's matter. Look at the diagram. Where's it going to exit to? Back in, okay? Because matter cannot be created or destroyed, only transformed. So it's going to go back into the system in some sense. And then they reference this word feedback loop. Have you guys ever heard of a feedback loop? And they reference it as what? What kind of feedback loops? Or what is a feedback loop? So your example, it could go back into the system. Now, it can go back into the system as an input or an increase to that change in a sense. And that's what I'm going to talk about next. You'll better understand loops if you look at them in terms of positive and negative loops. Now look at this picture. Here is, let's say we start here, because really in a cycle there's no starting point, and you're going to reference that when you do your projects. There's really nowhere to start in your explanation. You have to pick a point, okay? Because if it's a cycle, it can go in a perfect circle, or it can go and cut through the middle, or it can cut through the middle, go back up to the top. It just goes. So the change can happen anywhere. But let's say we start here. Let's start here. Ice melts, and what's released? What does it say there? Because I can't even see it.
As reflective ice disappears, darker ocean, water.
Okay, so we melt ice, and now we've got this darker ocean. Okay? And then temperatures rise, which lead to more ice melting. Here's another one. That's what they call a positive feedback loop, and I'll describe it better here. It's not that it's a positive effect. It's that the change occurs and it causes further change in that same direction. So it's usually, unfortunately, in environmental science, and actually a bad thing. So here we've got another one. We've got global warming, right? Or temperature rising on our planet. That leads to melting of the ice. The melting of the ice leads to the darker ocean, or as reflective ice disappears, darker oceans, water absorb more heat. So higher temperatures again. It's just the same thing. It's the same picture. Now, I'm going to give you another one. When Arctic ice melts, CO2 and let's say CH4 are released. Okay, anybody know what those gases are related to? Let's just go with CO2 for now. Okay, we're not even going to worry about CH4. CO2 is released. What do we know about CO2? It's carbon dioxide. What else? It's a greenhouse gas. Greenhouse gases cause what? Temperatures to what? Rise. Which leads to what? Which is global warming, okay? Or leads to global warming, which causes what to happen to ice? Melt, which when ice melts, what's released? Carbon dioxide, which causes, and it just doesn't stop, right? That's a positive feedback loop. So the change leads to a change in the same direction. Yes?
Now, couldn't it stop?
The reality is, and almost every scenario in your AP exam or questions are going to be referenced to positive feedback loops, because negative feedback loops, where did you hear this word, negative feedback loop? What class? Bio. It's usually bio, and here's a perfect example of your body temperature, which is a bio example. But the change, so again, negative sounds like it's bad. It's not necessarily bad. The change goes back into the system in the opposite direction. So your air conditioning, as we were just talking about, is another example. When you put the air on 75, your house will get to 75, and then what happens to the air? it turns off, and then the temperature rises, and then when it gets over 75, it turns back on. That's what a negative feedback loop is. And this is kind of the same thing. It's dealing with temperature. But most scenarios in environmental, and you're going to see as we progress through the chapter, are positive feedback loops. All right, so the systems is the introduction to help you understand the flow of matter through the ecosystem. But what technically flows through matter or through the ecosystems in terms of matter? And you should be able to answer this in 2 seconds because, no, we're doing matter. Remember, matter is matter and energy is energy. What elements? What elements? So if you say water, what's water? Hydrogen and oxygen. What else travels? Carbon. What else? Nitrogen. Chomps. Good job. Or chomps. I said cycles through the environment, and this slide says human body, so I'm talking about your human body. And actually, that's what cycles through the environment. Because remember I told you that everything you're doing goes through the biosphere. So it goes through every layer of Earth, including organisms. And these are the cycles, which are carbon, nitrogen, water, sulfur, and phosphorus. So if you look at these elements in your body, they combine in some form to make this cycling through the environment, okay?